We did finish up with number 49. This one here. Yep. So 50 and 51 are essentially the same exact thing. Outside times the whole. Exterior length times the whole length is equal to the exterior times the whole. Are there any questions on 50 or 51? Because I think we might have done those. Which one? Well, we could do it again. We've got time. So 51, so the exterior for one line would be 30 times the whole x plus 30 or 30 plus x. We can write it either way. The other side is going to be 27 times 27 plus 23. And now that I'm writing this out, I do remember doing this. Because, as I said yesterday, we can multiply, so we can do the one on the left. 30 times x is x. 30 times 30 is. The right side is all numbers, yes? So we can do it individually, or we can just type it into the calculator exactly as it's written and just get 1350. Then we would minus 900 on both sides, telling us 30x is equal to, divide both sides by 30, telling us x is, and that's it. Questions on any of this here? Let's look at the next two, 53 and 54. Which one of these do we want to look at? 54. So the tangent segment squared, the length of the tangent segment squared is equal to the exterior times the whole of the secant. So our tangent segment here is the square root of 1500. So we have the square root of 1500 squared is equal to the exterior, which is 24 times the whole, which is 24 plus 2x minus 6. What is the square root of 1500 squared? Because when we square root something, we're trying to find what number times itself gives us 1500, and then we square it. So it's undoing. The square root and square cancel each other out, just giving us the number inside. Over here, unfortunately, this time it's not all numbers. We have 2x in the middle. So the first thing we could do is just simplify what's inside the parentheses. 2x does not have any like terms, so it'll stay 2x. But 24 minus 6 is going to be plus 18. I do that so I'm not multiplying 24 by 3 numbers, just 2. Now the left-hand side's still going to stay 1500. 24 times 2 is x plus 24 times 18 is, it's going to be a decent number, 432. Now we just need to solve for the value of x. So I can subtract 432 from both sides. 48x, 4, 1068. And last but not least, we would divide both sides by 27. We get this here. Any questions on any of this here? Any questions on this one here? we'll do one more. I'll go on and do 53, and then we'll move on to the next type, because 54, I believe, is the exact same, or 55 is the same thing as what we just did. It's just a little bit simpler. Now, 53, the tangent segment is, so we have x squared is equal to 12 times 12 plus 15. Now, if we square x, we get squared. Now, the other side, luckily for us, is all numbers, so we could actually plug that in. And get because 144 would be 12 times 12, and then we'd have to add 12 times 15 to it. Now we would take the square root of both sides. And the square root of x squared is x. Square root of 324 is? And on the previous ones, the ones that we talked about yesterday, we added the plus and minus, yes? Now, if I plug that back in as the length, so this here would be negative 18. Well, can I have a length as negative 18? No. So this one here just is positive 18. But the one we talked about yesterday, the spot where the variable is at wasn't just x, it had a square with it. Because it was 2x squared minus or plus something. I think it was 2x squared plus 4. Because there was an x squared as part of the length, that negative became positive when we plugged it back in. Yes? Is there anything here that's going to affect whatever that number is and make it positive? No, there's no square. There's nothing to change the sign from negative to positive. So here the answer is just 18. You can't have it be a negative. Does that make sense, the difference between those two? If it had been x squared to begin with, okay, then we could have it be negative. But here, it's just going to be positive 18. Any other questions on this one here? Mm-hmm. So x squared, so we're squaring x, we're multiplying x by itself, which is x squared. Yep. Because here we're applying the square to it as part of the formula. The one before, it had it to begin with. I believe this is approaching into the home stretch. We only have these last few and then the ones with radius. Find the equation of a circle. Well, it might be helpful to have the general form. X minus h squared plus y minus k squared is equal to r squared. And the center of the circle is hk, and our radius is defined as r. Questions on 56 or 57? 57. So when we look at this here, thinking the center's right here, and we can check 1, 2, 3, 4. Okay, that's a distance of 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. Okay, so I did find the center. And I'm just counting out because, again, the center should be equal distance from the sides. That also tells me that here the radius is 4. The center is at negative 6 on the x and 6 on the y-axis. So our formula is x minus h. The h value is our value of the center. And the value of h is negative 6. Well, that's going to turn, so we would have x minus negative 6. A negative and a negative make a positive. So we can just write it as x plus 6 squared. Plus y minus k. Well, the k value is squared is equal to r squared. And 4 squared is so that's the answer. X plus 6 squared plus y minus 6 squared is equal to 16. And that's the equation of the circle. Any other questions on 56 or 57? Questions on 58 or 59? Okay, so the center is our h comma k, yes? And this here is where our h comes from, and this is where our almost, because our general equation is x minus h squared plus y minus k squared is equal to r squared, so x minus h. So what's inside the parentheses should be a subtraction sign. If it's not a subtraction and it's plus, it means the value of h has to be negative. Because the general formula is x minus h. Do we have a negative here? So the only way that... So really what we're looking at is not this here, but x minus negative 3 squared. The 4 is positive because it still has the subtraction from the original formula. Now, for this here, r squared is 100. The radius squared gives us 100, yes? So to find out what the radius is, I have to take the square root of 100. And the square root of 100 is 10. Now, if this radius does not come out to be a nice number, we can leave it in the radical form or whatever form we have it. Yes. Yes. Are y'all finished writing 59? Okay, because I'm going to erase this here to give myself a little more room. Right. Now, again, our general formula h, the x value of the center comes from the set of parentheses that has the x. So we have minus 4. So this would be positive 4, since it's the opposite sign. Yes. Because whenever we just have x squared by itself or y squared by itself, that value is 0. So if it had just been x squared plus y squared, the center is at 0, 0. Now to find the radius, we have to take the square root of. Okay, find out what the square root of 21 is. I think it, yeah. No. Square root of 21 is fine. Because if it'd give you, for like the square root of 20, it'll tell you that it's 2 square root of 5. That's the radius. Yes. Yeah, if it had been x plus 4 squared, it would have been negative 4. Questions on 58 or 59? Okay. Questions on 60 or 61? So I want to look at this here. Okay. So we can look at either one of these here. Which one do we want to look at? 60. So the general equation is x minus h squared plus y minus k squared is equal to the radius squared. So if I plug h in, h is what? -4. But that negative is going to make it positive. Plus y minus k squared, and k is the radius squared. Well, what's our radius? So we could write the square root of 3 squared in the here, or what is the square root of 3? That's it. We're just plugging this in. And a lot of times when I write this out, I'll write it out just like I did here, x minus, and then see what the center's x values is. Since it's -4, I can do 4. It's easy to change a negative into a positive. Change the minus sign into a plus sign, because all we have to do is add the vertical line. But that's it. Questions on this here? Do we want to look at 62 or 63? 63. So we do have the center. And the h value of the center is -4. So that's going to make it +4. And the y value is, I think it's just 2, -2, y minus 2. And they gave us the radius, which is, they didn't give us the radius, did they? No. So what we're going to need to do at this point here, since they did give us a point on the circle, because the radius is the distance from the center to a point on the circle, so we can use the distance formula. We have this here. Now, how we plug the numbers in isn't overly important. The big important thing is that you don't put x's with y's. So the two x values are what? -1 and -4, yes? -1 minus -4 squared plus. So we could say +4, -1 plus 4. And the two y values are -1 and -1 minus 2 squared. Is everything in there a number? Type it in exactly as we see it. Square root, parentheses, -1 plus 4, close parentheses, squared, plus, open parentheses, -1 minus 2, close parentheses, squared, enter. I want to fix that. That just seems a little funny. Three squared of 2. Let's see. So the plus sign in the middle is what's going to be the difference. And so the reason that we had the plus between the 1 and the 4 is because the actual sign is minus. So it would have been -1 minus -4. but the minus the -4 turns into the plus. Does that make sense? And without that addition sign in the middle, what it did was it took this, which would have been 3 squared, and multiplied, yep, by 3 squared, which is how it got towards that answer. Does that make a little more sense? So it is good to at least write some of the stuff out that way. I can keep track of where you're at. The distance is 3 squared of 2, but we need to square it to get to what the number in the formula is going to be. Well, 3 squared of 2 squared. 3 squared, 3 times 3 is? What is square root of 2 times square root of 2? Which is? 2. Square root of 4 is 2, so 9 times 2 is? And if you type that into the calculator, make sure to put parentheses around the 3 and square root of 2. Because there's a good chance that if you do 3 square root of 2 squared without the parentheses, it'll square the square root of 2, but not the 3, and give you 6. Also, in the calculator, if you did plug that in and gave you the answer as 3 square root of 2, if you hit the square button, don't hit anything else, hit the square button next, it'll put A and S with the square, which is grabbing the previous answer, and as long as the previous answer was our 3 square root of 2, it'll give us the right answer. Any other questions on these here? I'm not putting one of these here, 64, 65, on the test, because it's not that they're difficult, they're just time consuming. Now, huh? Yes. 30 and 31. These here. 30 or 31, which one do we want to look at? 31. Now, either case, it's similar in how it works. Because what we're wanting to find is, let me use this one, is the length from here to here. We want to find the radius. And that's the goal. Now, we're told one of the lengths is 7. Now, because this is 7 and this is 7, it means that this entire length is congruent to this length. Well, they told us BC is 3x plus 80. And our other length is 6x minus 64. So they're equal to each other. Now we just need to solve for the value of x. So what can we do first? Which will tell us that 80 is equal to minus 64. You can add 64 to both sides. And it would be really nice if whatever this is divisible by 3. Because that'd be 4, 144. So 4 and 4 is 8, plus 1 is 9. 9 is divisible by 3, so it does work. 4, so 12, 24 is 48. Okay. Any questions on this here so far? Okay. Does everybody have this kind of stuff copied down? Okay. Because I'm going to erase all that. That way, I can still write here, we can still look at the problem, and I don't have to scroll way down the page. Now, x equals 48. We've got to plug this back into one of them. Doesn't matter which. So we can say 3 times 48 minus, or plus 80. And we want to see what this value is. Well, since again it's all numbers, 3 times 40. So the entire length is 224. That's nice to know, but it's not helpful because we only want half of it because we're trying to make a right triangle. We're trying to find the sides of a right triangle. So half of 224 is 112. We have two sides of a right triangle. We want to find the hypotenuse, yes? So a squared plus b squared equals c squared. So our a value, or one of the values is 7, the other is 112, is equal to our radius squared. Yeah, both of those are numbers. So we can do 7 squared plus 112 squared, which tells us that r squared is equal to 12. 5, 9, 3. Well, we kind of expected, especially if one of the sides is 112. Square root both sides. Now this is not a nice number. Point. Let's go 22. I'm just rounding to the second decimal place. And I believe the answer key has something close to that. I went just one decimal place instead of two. At least do one or two. If you are unsure of it, just based off the decimals and how they look and how rounding might take place, put as many as you feel comfortable with. But that's it. Any other questions on this here? So your test is